I don't know about you, but if I was on a ship and I saw a glowing sphere of light suddenly floating around the top of the mast, I would be, I think this is the proper term for it, freaked out. But for centuries, sailors saw that all the time, and they thought the mysterious blue glow was a good omen because they associated it with the end of a storm. They called it St. Elmo's Fire, after St. Erasmus, the patron saint of sailors. But we now know that it's a natural phenomenon. When the pointed end of a ship's mast interacts with the heavily charged air, like during a storm, it can create a ball of plasma. Plasma is the fourth state of matter, after solid, liquid, and gas. And even though it makes up 99% of the visible universe, we didn't know plasma was a thing until the late 19th century. In 1879, Sir William Crookes, a British chemist, first discovered that he could make what he called radiant matter using a glass container with two electrodes in it, which he used to ionize the gas inside. This matter was later called plasma by American chemist Irving Langmuir in 1928 because he decided that it looked like blood plasma. Plasma is like a gas, but instead of containing neutral atoms or molecules, it's made of ions and electrons. So to create plasma, all you have to do is create conditions in which electrons get knocked off the particles in a gas. Sometimes this happens because the gas is hot. The extra energy knocks electrons out of their places, ionizing the gas. Other times, a powerful electric current can eject electrons from gas particles, turning that gas into plasma. But even though plasma essentially comes from gas, it acquires so many special properties that it's considered an entirely different state of matter. Normally, for example, gas isn't all that good at conducting electricity. Actually, it's often used as an insulator. But in plasma, there are so many detached electrons floating around, it becomes incredibly conductive. This conductivity shows up in lightning, for example. When a powerful current forms between two highly charged areas in the atmosphere, it passes through a long, skinny column of air, heating it to 5 times the temperature of the surface of the sun. Lightning is actually a trail of plasma. And since electric fields and magnetic fields are both the result of the same force, electromagnetism, plasma also turns out to be very responsive to magnetic fields. Researchers often use this when they're trying to control the stuff, to study it. But we also use plasma all the time in our everyday lives, like in fluorescent lights. When you turn on a fluorescent light, an electric current ionizes the gas in the bulb, usually argon with a little mercury, and it becomes plasma and interacts with a compound called phosphor to create light. So sure, you'll find plasma in all kinds of places on Earth, but in space, the stuff is everywhere. Stars, for example, are just giant balls of plasma. The tremendous heat generated by their fusion reactions has the same effect on atoms of gas as found in a Crookes tube or a fluorescent bulb, only much, much, much more so. And there's plasma between stars too, even between galaxies. We normally think about the space between stars and galaxies as a vacuum, and a lot of it essentially is, but there are a lot of places that have quite a lot of matter. It's just spread out over light years of empty space. And that too is plasma, pockets of gas that have been superheated into clouds of ions and electrons. Cosmologists think that up to 50% of the normal matter in the universe is strewn around between galaxies in this form, known as the intergalactic medium. So you don't have to be an old-timey sailor to witness the fourth state of matter. It's right over your head in those fluorescent lights and outside your window the next time a thunderstorm comes, and, well, all over the universe. Thanks for watching this episode of SciShow, especially to our Subbable subscribers who keep us energized. See what I did there? To learn how you can support us, just go to Subbable.com to learn more, and don't forget to go to YouTube.com/SciShow and subscribe.